Hey guys, uh, welcome to another video for test 2 preparation. And I just want to go over lab 4. Um, it was quite a tricky lab to do, and I think it would be good practice for the test coming up since it deals with strings and encryption and stuff. So let's get into it. Alright, lab 4 strings. Okay, so they gave us these functions we can use, and I'm sure you're familiar with them more or less by now. Okay, so task one, we're supposed to reverse words. Okay, so encryption is the process of converting data to an unrecognizable form. It is commonly used to protect sensitive information so that only authorized parties can view it. One such encryption method is to write each word with its letters in the reverse order. So, for example, given the plain text message, this problem is too easy for me. I am an amazing programmer. Do you agree? To encrypt this plain text, we take each word and reverse it to find the encrypted text. The first word, this, will become SIHT. The second word, problem, will become MELBORP. And then repeating this process will result in the encrypted message being that, okay? You are required to write a program that reads in from a file called named input.txt the plain text on an unknown number of lines, encrypts the plain text using a function written by you, leaves all other non-alphabetic characters in the plain text unchanged, and writes the encrypted message to a file named output.txt. Note that any text that will appear on a new line in the input should also appear on a new line in the output. So see the examples below. Okay, so we have two examples to test our code. Alright, so let's begin. Let me first write the. So I'm gonna just make the input uh, text really quickly. So the first line we had was this problem is too easy for me. Full stop. I am an amazing programmer. Do you agree? Okay, let me save that quickly. Alright, so let's put our normal stuff and see if we are actually uh, getting the correct information from the input file. Uh, Alright, okay, so since in this one we need to take entire lines so that we keep what is on the same line there. It's unlike taking maybe each character or each um, word and then changing. We need to take the whole line so that we know that what is in the first line stays there, second line stays in the second line, and so on. So I'm gonna make a variable called sentence. and it will be a string variable, and I'm just going to make sure there's nothing in it. Then I'm going to use a while loop because I don't know how many lines are going to come in. Well, from examples I can see, but in case there might be more lines. Well, the example 1 doesn't have the same as example 2, so that's why. All right, so when I use getLine, open brackets, and then write where it's coming from and where it's going to. So it's coming from in file and going into my variable called sentence. And then for now, what I want to do is make sure I am getting the correct information from the text file. All right, so I am getting the correct stuff. Okay, we know that that's okay. So in this uh, lab, this task, what I want to do is separate the words in the sentence. Okay. So I will do this in this function called encrypt. So encrypt will just take in sentence. So let's make that function quickly. So void, because I don't want to return anything for now. I can change that later. So encrypt, and then takes in a string sentence, right? And if you look at the example given, or in any case, what separates words is the space, right? So wherever we have a space, we know that the next word starts. Okay, so spaces will be how we separate the words in this case. So yeah. Okay, yeah. So since we're using spaces to separate the words, right? It that works fine right through, but the last word, agree, does not have a space next to it. Okay. So what I'm gonna do is pass in a space at the end, so that after agree there'll be a space. So right now, like, there's no space there. Okay. But then after this, it will be adding a space. Another thing the question mentioned was that if you have a full stop there, it should remain at that same place. So let's say I swap me around, it will become EM, and then at the end of EM there should be the full stop. So the full stop shouldn't come in front of this word, even though it's like in last place when it comes to this word. So all right, I'm going to run a for loop to pass through every single character, and then if it gets to a space, then we separate. If it gets to a punctuation mark, then we'll have to do something for that as well. So that's what we'll use. I think I spelled this wrong. Okay. Okay. Yes. So the first thing. So if I haven't seen any numbers in example 1 and 2, so I won't choose is lnum, I'll just use is alpha. And I'm testing. I'm passing through each character, right? So as the for loop runs, it will pass through there. So what this if statement says is that if the character you find in this string called sentence at position I is an alphabet, then do this bit of code, right? So if we do find that it's an alphabet, then what happens? So we like, okay, if you find an alphabet, you need to construct a word, right? So I'm gonna make a string variable called word. Make sure it is empty, and then I'm gonna use it here. So if you find that it's an alphabet, then take word and add whatever you had before with this new character coming in, right? So let's say the only the word this comes in. Okay, let's say this comes in. So T passes through. Is it an alphabet? Yes. So it takes word which is empty in the beginning and adds T, and then the loop runs again. It's now at H. H is an alphabet. Then it takes T, which is what was stored in word, and adds H, and then repeats the loop until, in this case that I just made, the word this gets stored in the variable word. Okay. Okay. So let's write another case. So if we find that it's a space, right? So is space within the sentence, right? So this um, so what this else if statement does, it checks if, so it checks if the sentence at I is a space, right? If there is a space, so if this space is true, what do you want to happen? Okay, so if you look at this example one, right, which is down here, so remember T gets stored in word, H, then I, then S, right? Then there's a space. So what the code will do is like, okay, once you get to a space, then we need to take, remember, we need to reverse the order of the letters in each word, right? So word, right? I'm gonna take word and I'm gonna make it equals to a function that I'm gonna make called reverse word, and I'm gonna pass word into it. Okay, hope that's not too confusing. So what's basically happening is that I'm gonna make a function just now called reverse word, and I'm passing in word. Remember, if we running this string from the beginning, T gets stored, H because they're all alphabets, right? Until S, a space comes up, right? So we want this word. The word is this. So this gets passed into reverse word, and what I want reverse word to do is um, uh, take S and put it first, and then I, and then H, then last T. and then store that result in Word. So what I'm expecting to get back from or at this point is SIHT, like that, SIHT. So I need to make another function. Please make it above because I'm using it in this function called encrypt, right? So I need to make it above so that when the whole code compiles and the cursor gets to this point, it doesn't say, okay, where is this function? Because it reads from top to bottom. So make it above. So you can see I need to return something from this function, right, to store it in here. So it won't be void. I'm returning a string, and the name of this function is reverse word, and it's gonna take in a string called word. Cool. So let's just go to Notepad and show how the words will be reversed. Okay. So far the word uh, this happens when I record. All right. I wanted to use. Okay. Oh, yeah. Okay. Let's try and use this. Black. Uh, okay. Okay. So the word this comes in, and then what the function reverse word is going to do is just read the loop from here, going backwards, right? So start from the last uh, character and go this way. So it's gonna run a loop from the minus, and that's all, and then return this result. So save this somewhere and then return it, and that's it. So yeah, okay, let's do it. I'm gonna run a for loop, but in this time it's gonna run from the word, the length of the word, right? -1, and the reason I put a -1 is because uh, remember you start indexing from 0, right? So you start indexing from 0. So this is 0, 1, 2, 3. So there's only the highest index is 3. So we need to, and the length of this word it's 4, right? So length is 4, but the index goes to 3. Cool. So that's why word.length -1, and then I must be greater than equals to 0 because the lowest index is 0, and I'm gonna go I minus minus. Excuse me. Okay, I'm just gonna put a return for now because this thing is giving me. I don't want to see all this. Okay. If you get this warning that there's an implicit conversion, so what's happening is that word.length is it's not an integer type, right? It's a constant something. But I'm just going to use double so that because remember double saves a larger number of digits. So and there's more space used to store doubles than integers, something like that. So yeah, it's not giving me errors anymore, and it will still perform like an integer. So don't worry if you see double and yeah, it's just counting. I'm counting in integers here. So positive integers. So I'm going to go downwards and I want to store it somewhere. So I'm gonna create a string, call it R word, short for reverse word, and I'm going to clear it in the beginning. And clearing is some type of way of initializing strings to be like empty. I'm making sure it's empty. I don't want anything funny to be added, right? So because this loop is gonna run multiple times, I need to add the previous characters and the new one that's gonna come in from here. So I need to add word at I. Alright, so let's go through this. So this comes in, the word this. So let's assume this cursor is where the loop starts. So it takes S and then passes it to R word through this line of code, and then gets to I, passes it, then H, then T, and then so the result is in R word, right? So I want to return R word because that's where my result is, okay? And yeah, that's how you reverse the word. Cool. So word will store R word, right? Which is this piece of code that we wrote. So, okay, so if you want to check if this function works, okay, or even if this function works, okay, let's first test if reverse word works. So, before I return, let's just see out our word and end the line. And since it's a function, I can use it down here, right? So I'm gonna comment out uh, this bit of code, which is my while loop for getting information from the text file. And I'm going to manually say sentence is equals to the word this, okay? And then I'm going to say, oh, I don't even have to do this. So just call reverse word and put in the word this. Make sure to use, remember to use the quotation marks. Alright, so as you can see here, it did reverse the word, right? So let's go on. That function works. That's what we know so far. We can test this piece of code as well. So I'm just gonna remove that C out from there. And then I'm going to C out at this point, right? So on the C out word. So I'm still expecting to see this, right? And then I'm going to call encrypt, and I'm gonna pass in the word this. But remember, our code Our function only separates words when there's a space at the end, so I will include that space there, then run it. So here's it. It does get printed out, right? Cool. So that works as well. So far, so good. So I'm just going to uncomment what we had previously. Okay, so we get our first word in there, right? And after we get that word in, we want to construct another sentence called eSentence, and the E will be short for encrypt. And I'm just going to clear it as well. Okay, so after you reverse the word, take whatever you have so far for sentence, and so far for sentence, and just add the new word, right? So in the beginning, each sentence is empty, and the variable word will be added to that. So far we'll have the word this in reverse stored in each sentence. Okay, and if you look down here, right, it doesn't have that space anymore. And why it doesn't is because this code gets executed if there's a space, and there's nowhere in this place where we're adding the space. Unlike here, when we found that sentence at I is an alphabet, we added the alphabet or that character at sentence dot at I to word, but in this case we're not adding the space anyway. So after this, just add a space like that. Okay. You can even check if that works before proceeding. So just comment this out again. Okay. Comment this out again. Okay, yeah. So this gets printed out in reverse, and can you see there? That space also gets included. Okay. So we have if it's an alphabet, to this, just add the character to the variable word, and then once you get to a space, then take that word that you got so far, what you've been building up, reverse it, and then store it in the variable word, and then pass that reversed word into my encrypted sentence and add a space at the end. And then after you're done with that, I want to clear the variable word because after the first word comes in, I want to remove what I've stored and then start the second word. So let me just bring up what the sentence was again. Oh, snap. I'm not see outing anything. Okay, so I'm just gonna comment this. I just wanna show you. Yes, so what I was saying was that after the space, I want the word problem to be stored in this variable called word, and I don't want any traces of the space or the word this to appear there anymore. So that's why I'm clearing the variable word. Okay, let's go on. So after you clear, then the loop will repeat for the word problem, and switch that up, and then is, and then to, then easy, then for, then me. So far so good. But then the problem comes here where we have two alphabets and a punctuation mark, okay? And it's a problem because our code so far does not know what to do with those punctuation marks, and it's basically gonna ignore it if we do this. So we'll have another if statement, and since we have punctuation marks, right, appearing before spaces, even there, we have a punctuation mark, then we have a space, punctuation mark, then we have a space, right? So I'm going to put the code here above the else if you find a space. So just above that. So else if I'm going to use is punctuation, right? Is punct, and I'm passing in sentence at I, which is a character, and if it is true that there is a punctuation mark, you want to probably store it somewhere, and then maybe, after you see, we need to remove the punctuation mark, store it somewhere, reverse the word. In this case, next to the full stop is the word, me. So we want to take me, reverse it, and then add the punctuation mark, and then add the space back, okay? So to do that, I'm going to make a variable of type char and call it punctuation. And this will store my punctuation marks, okay? And I'm just gonna assign it to a blank space, okay? And I do that because if I only use it, or initialize it here. So once I find a punctuation, right, I'll be like, okay, punctuation is gonna equals to sentence at I, right? That makes sense because we just found a punctuation mark at this place, so let it be equal there. And then let's say I want to use this variable punctuation somewhere else in the code, but I only equate it to something here. C plus, the IDE is going to be like, okay, wait, you're only initializing it here, but using it somewhere else, so you might get errors. So that's why I gave it the space, but it won't affect us anyway. All right, so if you find a punctuation, then do that, right? Put it in there. And then remember, our code won't, this for loop, or the code won't know that this is a separate word from that. The only way we separate it is with spaces, right? So all this is going to do is add the punctuation mark and then, okay, so go on. It's not going to know that after punctuation mark, the words ended, right? So I hope you understand what I'm saying. Okay, let's do a test run. So let's say the word, okay, let's say we're at this point here in the for loop, just before the M. So the M comes in, okay, so we're like, okay, it's an alphabet. We store it in here. Remember, word has been previously cleared. So at the moment, word will have M. Is there punctuation? No. Is there space? No. So that's the end of the for loop. Since I is not at the length of the sentence, we continue running. So I plus plus, and then now we at the E. Is E a character? Yes. Add it to the word, so now we have ME. Is there punctuation? No. Is there space? No. Loop ends again. We're like, okay, full stop. there's a punctuation mark. Okay, so now punctuation, holes, full stop, good. And then, right, it's not an alphabet, so it doesn't get stored there. Is there space? No. Okay, we go again. Uh, Space comes in. Okay, there's the space there. Then it's like, okay, is this an alphabet? No. Is the punctuation? No. Is there space? Yes. So what gets past? The word me comes in here. It gets turned into em. So whatever was in e sentence before, right? Plus. So now it goes whatever was there before. I'll just use that, and then em comes in. Okay, and then what happens? That's where we are, right? And then that's space because we added a space, and then that's it. So somehow, if you try and say, okay, Kevin, why don't we add punctuation and then add the space? Then I'll be like, okay, but then what about all the times, or what about the previous words, for example, this, where there's no punctuation? Then you'd be like, okay, uh, there's a space there, right? So somehow we'd be messing up every time we just add a space there, because then after the word this, there'll be like, what, an extra space and then problem and then an extra space and then is, and then, so we don't want that. Okay, so that's not a viable option. So we need to find a way to add this full stop and then put a space. Okay, so uh what I'm gonna do is make a boolean, okay, and call it is punctuation. Okay, and I'm gonna set it to false. So what my plan is to have two options in this else if statement. Okay, so one option, if is punctuation, where is it, is punctuation is false. Okay, then do this, so what it normally did. All right, but else if is punctuation is true, okay, then we want to do the same thing, but before we put the space in, we want to put in punctuation, then add the space, right? So, okay, then you want to clear the word, okay. But then you'd be like, okay, Kevin, in the beginning this is set to false, so nowhere in your code does it get set to true. Therefore, this else if statement uh never gets executed. So the only way we'd know if a punctuation came in is when is punct is true. So at this point, so below that, I'm gonna write is punctuation equals true. Okay, and then you could be like, okay, Kevin, so at the full stop, punctuation turns to true, and since there is no way where it's being turned to false, then after every word after that, there's gonna be a full stop that comes in. So we need a place to set it to false afterwards again. So after we added that specific punctuation, right? We clear the word and then we reset is punctuation to false again. Okay, so remember that in this else if statement, we reverse the word. Let's use me again, and let's see if this piece of code works. Okay, so cursor back there before the M. M comes in, it's an alphabet, added to word, though else if it's not punctuation, it's not a space, so okay, for loop ends, next word E, same thing, it's a alphabet gets passed to word, so we have ME so far. It's not a punctuation, it's not a space. Okay, continue. We get to the full stop. Is it an alphabet? No. Is it a punctuation mark? Yes. So in the uh, variable of type character called punctuation, we store the full stop, right? And then is punct is now true. So previously it was okay. Previously it was false. All right, now it's true. Okay, let's continue. We get to a space. Is it an alphabet? No. Is the punctuation? No. It's a space. Okay, let's go down here. So if is punctuation is false, what is not the case now because punctuation is true. So it comes here. It's like okay, punctuation is true. So take the word me, change it to em, and then take what you had previously for e-sentence, add em, then add punctuation, which is the full stop, and then add the space, and then clear the word. So now there's nothing there in word, and then punctuation is set to false again. So let's go on. It gets to, so it's done with the space, right? It gets to I, takes I, okay, I is an alphabet, pass it to word, good. It's not punctuation, not a space. Okay, next time it runs, there's a space. Is alpha? No. Is punctuation? No. Is it a space? Yes, it's true. But remember, is punctuation was set to false here. So then this code executes. So word gets reversed. So if I gets reversed, it's still I. E sentence will now have em dot. Remember, because e sentence here is this em full stop and then space. Sorry, the space comes from here as well. Remember, there was that space there. So space, and then I comes in, and then clear the word, so I gets removed, and then the loop continues. So far that's covered, right? That makes sense. Is there anything else that we need to do? I'm thinking no. Oh yes. Okay. So we've made an if statement for alphabets, we've made one for punctuations, and we've made one for spaces. So does that cover every single thing we see here? Yes, it does. But in case it didn't, okay, so this if statement, wait, else if, okay, so this else if ends there. So let's say you get something that's not part of the above list, right? So just add it to the e sentence. So in case maybe there was a number or something we didn't get we didn't get or we didn't read about in the brief. Okay, so you'd have this statement. Please don't forget to use, what is that thing? A style indenting or whatever, please. And I know you can do it in code blocks easily. You just need to select the piece of code you want to change and then right click and then it does it for you. So do that. Okay, so at this, okay. After that, let's return a string. So I'm going to change encrypt from void to string function, and then I'm going to return eSentence, right, which has my encrypted sentence. And then in my while loop, oh yeah, I'm going to say sentence will equals to the return from the encrypt function, which is eSentence, right? And what I just need to give it is a sentence. And remember, we're adding that space because the way we separate or get notified uh, when to make a word is by using spaces. What I'm talking about is that's when we know we have a word, and then we do our clearing and stuff. So okay, I'm gonna see out the sentence and then see what we get. Okay, so that matches with this output, and our punctuation marks are also in the correct place. But the only thing we have a problem with, if you can look here at the bottom, is that we have this extra space. And the reason we have the extra space is because of this, right? So every time like the last word had a punctuation, right? So I know that this piece of code is going to be executed. So that space gets added in the end. And what I want to do afterwards is erase, right? So I'm just going to erase the last character in the string sentence. And how I do that, I'm going to use sentence.length again. I'm going to use -1 because remember, as I said, this uses indices, right? And since I want the last indice, remember we start indexing from 0. So the last character will be the size of the string -1. And I want to erase one character. So start at the last position and erase 1. And is there anything else? Nope. I'm going to run this and see. Okay, so if you can see now, that space is no longer there, right? So there was a space there, it's no longer there. And okay, it works for the first example. Let's try the second example. So I'm just gonna write it out. So expecting the world to treat you fairly because you are a good person is a little like expecting simple not to attack you because you are a vegetarian. Full stop. Let me just save this. Okay, so I'm gonna run code again, and yeah, okay, so that matches with the code over here, and we're done. So last thing you want to do is take it to your output file, right? Output.txt. So out file dot open output dot text, and then put that there. Okay, and run your code. Make sure there's no console output, no console input. Return 0. Code uh, successfully run, and that's it, guys. Once I show you my output in my output file. There. Yes, so there it is. Just save nicely and safely. Okay. Uh, okay. Yeah, so we're done. Alright. I then want to do task 2. Okay, so I'm gonna like wipe everything out from this piece of code, so it's gone. Okay, let's go to task 2. So please pay attention because I feel like this might be very important in the test. And let me just check if okay, I'm still recording. Okay, so this is quite tricky, so you really need to pay attention because we're gonna manipulate the strings quite a bit here. All right, so pick Latin. Write a program that converts an input string into the Pig Latin form. The rules for converting a string into Pig Latin form are as follows. So there's three scenarios they gave us. They're like, okay, if it's a vowel, if the string begins with a vowel, add the string dash way at the end of the string. For example, the Pig Latin form of the string I is I way. And like if the string does not begin with a vowel, first add dash at the end of the string, then rotate the string one character at a time. That is, move the first character of the string to the end of the string until the first character of the string becomes a vowel. Then add the string A to the end or at the end. For example, the Pig Latin form of the string there is, yes, that word. Strings such as numbers contain vowels. The Pig Latin form of the string 1234 is 1234 dash way. This is the Pig Latin form of the string that has no vowels in it, is the string followed by the string way. Okay, so as usual, read an input from a file named input.txt, convert the input to Pig Latin using a function returned by you, and write the converted text to an output file named output.txt. So we have two examples here again. And yes, let's begin to program this thing. So three conditions given for three scenarios, and possibly um, uh, one or more functions gonna be used here because yeah, it's quite a bit. So first things first, let me record or let me make the input file, right? So uh, that'll no that'll to pig that'll 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 like that. Ah man, this autocorrect sucks. And then farmer hobbit. Cool. Just gonna save that and then let's begin to program. So uh, bring your normal stuff down there. Uh, First check if you are bringing in the string, I mean the text from the input file correctly. So I'm just going to create a string variable called sentence again. And I'm going to make a normal, not make, but I'm going to open our text file as usual. And in this one, remember always use a while loop because example 1 and 2 don't take the same amount of lines, right? Example 2 has like 9 lines and example 1 has 2 lines. So please use a while loop. Do yourself a favor. And since I'm not going to take in one variable at a time because I don't know, uh, there's no way I figured out yet to, if you look at the brief, like to stop at 2 and use some type of identifier to say, okay, this is where the line ends and then the next line begins. So even here, it's like you got a fast car. I don't know how to say or tell the program that, okay, uh, just write what you got so far on one line and then uh, take just know that you're starting a second line now. So I'm not going to take in one variable at a time, or what I mean, I'm not going to take in that'll and then change it and then take in two and then change it and take in pig and then change it. I'm going to take in this entire line, change that, store it in my, change it, put it in my out file, and then take in this one and then change it, store it in out file, and so on and so on. Okay. So get line, and then remember the way you use get line is where it's coming from, comma, where you're storing it, and then I'm going to make sure that we are actually getting the right stuff. Alright, so first line's correct, second line's correct. Alright, so now that we know the sentences are actually coming in correctly, I'm just going to make a function called encrypt like I always do, and it will take in sentence. Okay, and I'm just gonna make it above here, and for now it's gonna be void, and it takes in a string called sentence. Excuse me. Okay, cool. Right. So let us do the first condition. The first one says if the string begins with a vowel at the string, excuse me, dash way at the end of the string. For example, the Greek Latin form of the string I is I way. Okay, so can you see she actually gave you an example to test your code with? So she's trying to show you that you should test every single piece of code you write. All right, so if, wow, okay, this is gonna be a bit tricky. Okay, so first things first, we need to first separate, oh, yeah, I wrote it here. So we first need to separate words, right? Each word in the sentence. So I'm going to make a for loop. It runs from the first character to the last character. From left to right. And if it's an alphabet, is alpha, uh, is alpha right at the current character as I passes from left to right. If that's true, okay, then you want to be constructing your word. So word equals to word plus sentence at I. Okay, don't forget to actually make the variable word and make sure that it is empty. Okay, there. And what are you expecting? Okay, cool. Word. Okay. So once we have accumulated a word, we know that it gets separated by a space. Oh yeah. So at the end there's no space, right? So I'm gonna add a space here, just for the last word to also be able uh to know that actually do is also a word. There needs to be a space after the O. Okay, so that's why I'm adding a space to the sentence, right, which is this text. So when it gets passed to encrypt, it becomes sentence plus a space at the end. Okay. Uh, yeah, and that's a property of a string. You can add other string. You can add strings together, and they like using the word concatenate. So you can concatenate strings together and make new strings. Okay. So word is equals to word plus the character coming in, if the character coming in is an alphabet. And else if you find that it's a space, is space sentence and I. Remember that's how our words are separated by spaces. Uh, what do you want to do? Yes. So once you find a space, we have a word that's established. Okay. We have to take that word and then do our whole encryption thingies. So the first thing is if the string begins with a vowel at the string way at the end of the string. For example, yeah, that. Okay, so how do we know if it's a vowel, right? There's no special function in C++ that says, okay, use is vowel. Is there such a thing as is vowel? No. Okay, So we're gonna have to make one. So make a string, call it vowels, and then A E I O U. Done. Okay, so you've now made a way to detect vowels. So um, as you can see, there's not one vowel, right? There's one, two, three. There's five vowels. So in this, once you get a space, okay, we need to test the first. We need to test if the first character in that word you just constructed, right, which is the T, is equals to any vowel sound. So what I'm going to, does it still not work? Wow. Alright, guys, don't steal my information. I just wanna get my pencil to work so I can actually write stuff down. So I don't know why it's doing this. Yes, cool. It's connected. So now I can write nicely. Okay, so to test this first piece of code for vowels, I'm going to use this, okay? But remember, our vowels are in this form. So remember, we need to check if the first character of the word is one of these vowel sounds, right? And how would you do that? You would say a word um, at zero, but you can't use that format, right? So at zero. Well, you could use, because strings are arrays of characters, you could use that because that's array format, but I'm not going to use that. I'm going to stick with this. And you need to somehow equate that to the vowels, right? But since there are multiple vowels, you need to somehow index them. So you need to like say, okay, is it A? Then be like, no. Then is it E? And you'd be like, yeah. And then you know that it's one of the vowels, then you do something later on. So maybe put this in an if statement and then do something later on once you found that, okay, these are vowel. In this case, we take I and then we add way and it becomes I way, like that. All right, so we're going to need a for loop to run through this. So let's do that. All right, in the else if statement, you're going to have a for loop. Uh, it's going to start at 0, which is the first vowel, and go up to uh, the end of vowels, right? The last vowel, and go from left to right. In this case, it doesn't really matter. Okay. And what you want to do is check if word dot at 0, oh sorry, 0 is equals to vowels at I. And if it is, then take word and add. What are we adding? We're adding way. So dash way. Done. So after you're done with that word, what do we have to do? You need to add it to your new sentence, which will be your encrypted sentence, which I will name new sentence. And I just want to clear it in the beginning so that there's nothing inside. So after I have a word, I pass it to eSentence. Good. Good. Okay. So that's for the first case there. And since we like checking if our code actually works, let's do that. So if, okay, then else if ends here. So just before our else if ends, I want to see out the word you just constructed, right? But okay, let's see out here. Okay. Um, yes, encrypt. Okay, so instead of encrypting this, I'm gonna replace. Okay, let's comment this out. I'm gonna. Let me not confuse. All right, so I'm going to encrypt the word I, right? I like this. It appeared in this example, so I'm expecting iWay to be returned. And remember, I put a space to know that this is where the word ends. All right, see, iWay comes out, so that piece of code works. Let's go on. What do you want to do next? So if the string does not begin with a vowel, right? We need to add a dash at the end of the string. So let's do that. So if uh, you find that, then do that. Okay. Um, so this is where the for loop ends. So after this for loop executes, that means that the word's been changed, right? And uh, if this didn't work, okay, let's see. If space, then if is equals to one of the vowels, do that, right? So I can't write an else statement here because remember it needs to pass through all the vowel sounds before something happens. Then we only know that, yeah, nothing happened. All right, so after the for loop, let's write if word dot add. Okay. So let's make a boolean, right? This will be called is vowels or is a vowel, and I'm gonna set it to uh false. Hmm. Okay, so I set it to false, and then uh, 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 let's set it to true in the beginning. So true. So it's true. So this piece of code will happen, and then right. So now after this, okay. Ah, let's see. Yeah, okay, let's set it to false. False. Right. So if it did find a vowel, then is vowel will be set to true, right? So now we know that is vowel gets set to true when we did find that the first letter is begins with a vowel. Okay, so the word begins with a vowel. So outside this for loop, if is vowel is false, what does that mean? That means that this code didn't happen. And the only way this code doesn't happen is if the word does not begin with a vowel sound. Okay, we're still in the else if for space, so then we have one word that comes in and then we do stuff. Alright, so if it is not a vowel, what we want to do is uh, 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 what can we say? We want to do the rotating of the word, right? So we'll take the word and make it equal to a rotated version of the word. So I'm making a function called rotate word, and I will pass in word, and I want to pass in the vowels as well. And the reason I want to pass in the vowels as well is because this will help me see. Okay, it says move the first character of the string to the end of the string until the first character of the string becomes a vowel. So I don't want to have the in the function called rotate word and have another set of vowels. I can just use the same list that I made here. Okay. And since I'm using rotate word in the encrypt function, I'm going to need to make the definition of rotate word above that. Okay. And since I am initializing or equating the variable word to rotate word, I therefore need to return something from this function called rotate word. So I'm going to make it a type string because I want to return a string, and it's called the function is called rotate word. It takes in a string word and another string for vowels. And then I'm just gonna write some return because I don't want some errors to appear. Okay, for now I can change what I'm returning later. Okay, so if the word's not a vowel sound, we get here, we come to the function rotate word, so we call it rotate word. And what do we need to do? Uh, let's draw a diagram. So let's say the word uh, that will come in, which according to the example is actually the first word, right? So what we need to do is take that will add a space at the end of the string, and then we need to rotate, right? Whatever's in the front goes to the back until we have some vowel. So A is a vowel, right? So at the A, we then know, okay, we have a vowel. And then after we get to the vowel, we then add the string A to the end. So after that, we'll add A. So let's do that step by step. That will, then you put a space, then you'll have T go to the end, then you'd have H go to the end, then you have, yes, a vowel in the beginning. Then what you do is add A to the end. So this is what we are looking for the first word. Uh, okay. Now remember what I said before. We have five vowel sounds. So somehow we need to check for A, E, I, O, U at this point, and then rotate, and then look for A, E, I, O, U again, and then rotate, and then look for A, E, I, O, U again. Okay, because um, if this was a U and you only check for A, it'll continue going, it'll never stop, right? So in the case where we have a word where there might be the only vowel sound U in it, then this is necessary or anything besides A. Okay, so let's try and code that. Cool. Okay, rotate word. Am I still recording? Yes. Okay, rotate word. Uh, you have your vowels, you have the word. Okay, okay. What do I need to do? First things first. Take word and add the dash. Done. After adding the dash, you need to check uh, if word at the beginning is equals to a vowel sound. Sorry, not vowel sound. A vowel at, let's say, I. Okay, so I'm gonna need to run a loop, and I is equals to 0. I would run the length of um, the vowel sounds, so to all the vowel sounds, the vowels, and check if at one of them you do find the beginning of the word. All right, so we know for a fact in the beginning it's not going to work, right? Because we have a sort of a flag for is vowels, so we made it a boolean, right? Set it to false, and it will remain false unless this vowel code gets executed. Since it is false for the first case, which is the word that, so like that, okay, this code gets executed. Yes. So at this point, we have that code and a dash coming in. All right, so we know that if we do find a vowel sound, let's say we're gonna come out of this entire function and return the word, okay? Because that's all this code's doing. It needs to rotate the word until it gets to a vowel sound. But yes, before it does that, it needs to take the word and add what at the end? A. A. Okay. So after adding A, yeah, then you can return the word. Okay. So now again, we can't write else start rotating because this for loop needs to run for all the vowel sounds. Remember, there is A, E, I, O, U, and A, E, I, O, U needs to run there. Okay, so you need to have something outside here where um, you rotate the word. And my method of rotating is going to be as follows. So That's what we have, right? What I'm gonna do is oh, yes. So what I'm gonna do is erase t. So then the string will become like this, right? And then I'm gonna add t here. So I'm going to store t in some temporary variable, right? Then delete t from so then we'll have HATLL, and then you would say HATLL plus temp, and then you'd have this result coming out. So we can keep running this code until we get to that A or vowel that we want, and then return, and then do our add of AY and then return. Okay, so let us make a char variable called temp. Remember, it's just going to store the first character of the string, so I can make it type char. So after this for loop runs, I'm gonna have um, temp will equals to word at 0. Okay, then I'm going to take word and erase the first character. Remember, it starts indexing at 0, and I'm only gonna erase one character. And then I'm gonna take word and add temp to it, um, and I'm done. Okay, so based on the way I wrote this, it's gonna execute only once, right? Because there's no loop, it's inside. So I wanna make another loop, okay? But I don't know how many times I need to rotate the word until I get to the character. So I'm gonna use a while loop. And I'm gonna put the stuff inside. Okay. So when regards to when this while loop will end, oh yeah. Okay. So so far in all the words I can think of, every word has a vowel sound in it, right? So in the first word we have, there's one vowel sound, which is A. I mean one vowel, which is A. And um, 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 when we do get to an A or any vowel sound, remember we have this return, which just takes us out of this whole function and takes us back down. Yeah, okay. So that could be some sort of exit out of this loop. So I could make it a loop that doesn't end. What do you call it? Infinite loop or something. But that's not good coding practice, right? Uh, Another way we could end the while loop is like, okay, you've checked the whole word and you couldn't find a vowel sound, therefore it does not exist in the word, right? So then I need to make some type of counter that runs from 0 up to the last character in the word. So once I know that I've rotated every single once I know I've rotated every single character from front to back, then I know, okay, the vowel doesn't exist, and then I can just return whatever word I get from there. So that's what I'm gonna do now. Okay, so I'm gonna make uh, an integer called counter. Let it be initialized to 0, and then I'm gonna be like, so while counter is less than the length of the word, right? You can do this code. Where are we? All right. Let me just try to indent this nicely because right now, oh, I think there's an easier way of doing this. Oh no, that didn't work. Yeah, no, I can't do it. I don't know how to do that. I'll do it manually. Yeah, hope that's a bit more clear. Oh, hope that is a bit more clear for you guys to read. So our while loop ends down there. Our for loop ends over here. Okay. So the while loop uh, begins here. It goes to this for loop. It compares every single vowel sound to the beginning of the word. Let's say it doesn't find that. Yeah, it doesn't match any of the vowel sounds, right? I mean, it doesn't match to any of the vowels. Keep saying vowel sounds. Okay, then it stores the first character in temp. It then erases the first alphabet, which we stored in temp, right? So we just erase it and then add it to the back. That's a way of rotating. And then, so we want to say counter plus plus, right? So every time I increase counter, it means that some rotation had happened. And if we rotate every single character in the word, uh, remember, okay, we rotate once, this for loop executes. We rotate another time, this for loop executes. We rotate another time, this for loop executes because it's in the while loop, right? So there's only two ways this while loop will break. It's if we've rotated every single character, or let's do that so to make sure, or it found the vowel sound and returned the word. Okay, so I wanna check if this piece of code works, and okay, so I'm gonna come to main again, and I'm not gonna call encrypt. I'm gonna call rotate word. Am I still recording? Yes. Okay, so rotate word and then take in, yes, it's a return type. Okay. Okay, I'm gonna remove the return, make it void for now. Hi. Okay, let's just leave it as a string. Okay, let's return the word at the end. Okay, so rotate word and then I'm gonna pass in for the word that's getting passed in. Repeat sorry. And then my vowels A E I O U semicolon. So okay, let's do this. So I'm going to show you what it looks like when it rotates every single character, and then I'll also show you the final word that gets returned. Okay. Um, yes. Okay. So far, all this looks cool. Let's run the code. All right. So, okay. For some, oh, okay. I forgot to put word is equals to word plus temp. Okay, let's run again. Yes. Okay, so the T gets deleted, gets moved to the back. Then the H gets deleted, gets added to the back. So we have A, right? So it realizes that, okay, A is a vowel. So it takes the previous answer, which was ATLL-TH, and adds that AY to the end, and it returns. It's done. It doesn't rotate more than that. So uh, that works. Okay, so we can assume that this word gets returned back down here. So after we receive that word, we take eSentence and add the word we just received. After we receive a word, we clear the variable word so that the next word that comes in is clear. And this vowel will remain, or it will stay in its default state, which is false, right? Good. False. Good. Okay, so else if there's a space to this, done, right? And then so if we have a space, that's a word. If it is a vowel, to that. If it's not a vowel, to that. Then we have else. So example, if there's numbers, right? What do we need to do? We need to take the word. No, this is not in a good place. Uh, so if there is if, I'm trying to implement the last condition. So strings such as contains no vowels. Oh, so this is not even an alphabet. So if it's an alphabet, do that. Oh, okay, no. Else if you find a space. Okay. So else if um is alpha. Oh no. It needs to be in this. Once you find a space, whatever you got is a word, right? So okay, this runs for vowels. This runs if there's no vowel in the beginning. Um, so I'll have else if is vowel is false, is alpha at sentence dot at I. No, but that's a space. Ah, yani. So, okay, if that, else if that, else if is number, okay, is number at sentence, no, this is number needs to be in the space, okay, if, so let's have an else if is val is false, so that above code didn't happen, this, and is number is true. Sorry, add sentence dot at I. I'm just thinking, guys. Sorry if I'm quiet. Alright, so you're just gonna take the word and add what was it? Dash way to it. Okay, dash way. This there might be a condition that might mess this up, but I doubt. Okay, the only way this whole statement will mess up if you have something like K9113, like, you know what I'm saying? So you have some alphabet there, right? So it gets added. Hmm. Hmm. All right, let's just leave that as that. Else if, all right. Else if you find something that was not part of alphabets or spaces, then just add it to the sentence. Yeah. Um. Okay. So for loop. Let's see where you end. You end here. Then I want to see out the sentence for now. Right. So we checked if our individual functions work. So rotate word works, and the other conditions for encrypt works. Right. I'm gonna uncomment this. So what we'd have is just encrypt coming in. Let's run it and see. Whoa, what is going on? What is going on? Um, oh, I need to clear word here. So word dot clear. And after adding the word to each sentence, we need to add a space. So add a space there, add a space there. Add a space here. That's it. Okay, so this is what I get. So let's see. ATL good. Amafe. Okay. Cool. Okay, so that matches with my output over there. So far so good. I just want to put in this text. I know I always tell you not to copy and paste, but uh, let me show you what happens when you copy and paste. Can you see it's already taking these numbers? So you need to kind of remove all the numbers and make sure the ends don't have special characters or spaces at the end. Okay. Let's save this and then let me check if it matches. Yeah. Okay, that matches. Let's run and see. Hopefully it works. Please work. No. What are you saying? What are you saying? Talk to me, Code. Talk to me. Out of range. Hmm, 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 hmm. What is going on? What is out of range? What? Yeah, you see. Now, me, I'm gonna type this whole thing out because I don't want this funny stuff to happen. How can it be out of range? I'm comparing. Alright, let me just take that first line and run this code again. What? It's still out of. I is 1. Okay, so it's showing me that it's 1. So if I is 1, it's at A. So it's comparing F with A. So what is going on? What am I doing wrong? Terminating with uncaught exception of type standard out of range basic string. Out of range? Hmm. Okay. Hello works. How is this giving me errors? Ah, man. Hello. Uh, hello. Okay, cool. So you start giving me problems when how did the first I so that sentence works. So when I try you got a fast car. You got a fast car. Why are you not working? What? Sure. Okay. Hmm. Um, I'm trying to find out what the problem is. Is it exception? Okay. You got a fast car. Uh-huh. And then what's the problem? Compressed pair element. Int I had one word is equals to standard string compressed. So is this out of range? Okay, let's try. I just want to check. No. So what are you telling me? Okay, I'm just gonna comment this out until I figure out what is going wrong. Okay, so um, for some reason, this piece of code is bugging out. Okay, so I'm gonna try use the array style of Really? I feel like this is nonsense. Why are you going out of? What is the problem? You got a fast car. You got a fast car. Man, okay. Yo, guys, I'm sorry that this video will take extra long, but I need to figure out what is going wrong here. See, you got A. What about fast car? Why do you discard those? Um, you got a fast car. Uh, um, yo, what? Word dot at zero. Okay, just see out word every point here. I want to see it construct the word you. So you got a. Okay. So A only has one um character word is gonna. So what is the problem? What dot at zero? Even if it's just one, even if it's one, um, the length is one. It should still work. It's zero. At zero. Ah man, if I use it like this, it still gives me problems. Oh, so you got a fast car. You got a. What happened to fast car? This is so weird. I'm gonna leave it like this. Um, so the problem, am I still recording? So the problem I have now is that when I get to a word that has one character only, it's not allowing me to use this format and saying it's going out of scope, out of the string scope. Uh, okay. I can make a temporary variable. Alright, and say that better place to put it be on top, right? So as soon as it comes in, just say temp. Did I use I twice? Yes. Okay. I see where the problem might be. Please work. So let's use J instead of I because I have I on top already. Please work. You are still going out of scope. Why? Okay, let's try and do this. Semicolon. Okay, that works. Dude, like, yo, bruh, yo, that was bad. Alright, so let's put in the rest of this thing and then call it a video. Cause like, bruh, I want a ticket. No man, undo. I did put in the whole thing somewhere. Alright, save. Oh no, before I run, I need to remove the C out somewhere. Excuse me. Okay. Okay. This is wrong.
Alright, Mama, sweet dreams, everybody.
This is wrong. What email? Okay, okay, okay. Alright, so everywhere where I have everywhere where I have one character, right? It's giving me some big issues. Some of them will just yes. Some of them will just do the non-vowel. So this is probably code for rotating the word, and this just put a dash there. So probably doesn't even know what doesn't match. So it needs to match the to lower version of this. To lower version of temp, right? That's the first thing I noticed because stuff like capital I doesn't match with A, I, O, U. Let's run. That should fix at least that piece. Then we can fix everything. Okay, so it still didn't fix it. Yeah, I wait. Why are you doing this to me, Temp? Void I equals temp. Where um okay guys, I'm gonna make a follow-up video because I need to actually sit down with this and hopefully sort it out. We're almost there. It's just that places where I have I alone, it messes up. And where else? A, it also messes up. But the rest is good. It matches. So, okay, let's try and fix it quickly. So, uh, every time you have a word that's length is less than or equals to 1, then it's definitely a vowel sound. So, uh, so I have to make it in such a case that this piece of code doesn't happen. So, alright, that was fine actually. So if the word's length is 1, then just take the word, let's say it's word plus dash way. And then I'll have an else here, right? So this is what I call patching your code up. And it's bad because there's something you didn't account for. And you're just trying to make sure your code works. So you actually some sort of guessing I'm doing to make sure. Ah, ah, ah. So now it's it takes okay, look at the first line. It takes a way and then still adds a to it. So else if do this. And I need to set is val to true here. Yeah. Patching code, brute force. Yeah. So like What? There's like a lot of words that just disappeared. Yeah, guys. I'm gonna need to make a follow-up video here. Okay. So e-sentence. Alright, so if so I'm just checking where this is space, okay? So if the word length is 1, do this, else if it's greater than 1, you need to not end here. Actually need to end here. Headway and a space. Alright guys, it works, okay, but I don't like the fact that I had to like patch my code up. This is, out of all the test preps I've done, this code was probably like the most challenging encryption I've had to do. And I'm just gonna recap. Am I still recording? Yeah. Alright, so I'm just gonna recap and then uh, end the video, okay? So, oh yeah, don't forget to erase afterwards. So sentence dot erase the last character, which is sentence dot length -1 and 1 character. Alright, so we get our first line. Passing to encrypt, put a space to separate our words. So we come to encrypt, okay? We run a for loop and we run the entire length of the sentence from left to right, so from 0 going up in index values. So this temp wasn't needed, but anyway, I'll leave it there. So I just stored the current sentence at temp. So for now, don't worry about that. Okay, I'll show you why it was needed. So if, right, we do find that the word is an alphabet, then keep adding it to, so construct your word, take a character, add it to word, it'll become your new word. Keep doing that until you get to a space. Once you get to a space, right, if the length of the word is equals to 1, meaning you have words like I or what else? A, basically I and A, excuse me, then take that word, which is going to be I or A, and add way, and then add it to your encrypted sentence, and then clear the word, okay? Else, if the length is greater than 1, then you're going to perform all this piece of code. So what this code does, it runs there. Oh, and why, if the length is 1, do we just add way? Because I assume that every word you have that has one character only in a sentence is basically going to be a vowel. If you can think of any other word, you can suggest it to me that's not a vowel sound, and I'll make a condition for that. But besides that, yeah. And then else if it's greater than 1, you're going to run the first character, right? Which remember was saved as see, this is what I don't like. I'm gonna change it to word dot at 0. That shows me that it's the first character of the word. And then if I do find that it's a vowel, just add way to it, add it to each sentence and add a space. Make the boolean is vowel true and then clear the word. So the reason why we made is vowel true is that uh, if it was not a vowel, then we'd have to rotate the word, remember? That takes in word and the vowel sound. That code runs a while loop. Well, it first adds dash and runs a while loop for the length of the word and compares if the first alphabet in the word matches with the vowel. If it doesn't, it rotates the word using this process and then runs this loop to check for a vowel again and continuously does that until it finds a vowel, at which it will return the rotated word. If it did not find the vowel, it will just return the word in its final rotated form. So that gets passed to this variable word, and then e-sentence will equals to the previous e-sentence that we had, so probably maybe previous words or whatever, and then add this new word that we just rotated, and then add a space, and then clear that word so that we can continue taking in the next word. So if, and then this else if that we had was for times when we had numbers. Okay, so if you find, excuse me, if you find a word that has numbers in it, you check the word add way and add a space. Okay, and all this gets performed when the length is greater than 1. Okay, so if you find that what is this for then? Oh, yes. So that's where the else if statement ends for greater than 1, and this is where the else if statement ends for spaces. So if we don't find an alphabet, don't find a space, just take what you find and add it to each sentence. So I'm assuming this piece of code doesn't actually take place because we always either have an alphabet or a space. So let's say we have some punctuation mark, and the punctuation mark would just be added as is, and then I see out each sentence. So that's what gets printed here at the bottom. So let's just finish up this code. I'm gonna return each sentence, so I'm gonna make encrypt the function return a string, and I'm gonna return each sentence. Okay, and then I'm gonna say sentence equals to that. Then I erase the last character because I don't want that space at the end, right? And then OF stream out file, and then out file dot open output dot txt. Then out file, sentence and line, and then in file dot close out file dot close. Cool. Let's run this. Okay. So it's still complaining about this. I'm gonna put it back to temp. Put back temp in here. Okay, let's see if it actually appears. In output file. Okay, it does. There's probably a better way to code this thing. But it will need more thinking ahead. And yeah, just make it look cleaner. Cause this is very dirty code in terms of the way I wrote it. And that's why it was a bit difficult also to explain what I did. But it was a lab, and I don't expect you to get something of this level of difficulty. But in case you do, at least you have something to look at, right? So thank you for watching, guys. I think this is the last video I make before you write. If you do want me to make another video, please WhatsApp me or email me the test you want me to do, and I'll do it for you. Thanks, guys. Bye.